For the better part of a century, physics has been chasing this beautiful idea, a single, elegant theory that could finally unite all the forces of nature. We're talking about everything from the gentle pull of gravity to the insane power locked inside an atom. It's the Holy Grail, right? But the path to get there has been, well, let's just say it's been tough. So today, let's dive into a wild new idea that suggests we might have been looking in all the wrong places.
So why the roadblock? I mean, why is this grand unification idea just stalled for so long? The problem isn't that our current theories are wrong. Actually, it's the opposite. They are spectacularly, unbelievably right. The real problem is that our two best descriptions of the universe, well, they just don't play well together.
On one side, you've got Einstein's general relativity. It is a masterpiece that flawlessly describes the grand dance of planets, stars, and galaxies. Then, on the other side, you have quantum field theory, which is our incredibly precise map of the tiny, bizarre world of subatomic particles. They're like two completely separate rulebooks for two different scales, and they're written in totally different languages. Okay, so this gets us right to the heart of the puzzle. The struggle isn't just about finding some clever math to stitch these two theories together. A really radical new framework is proposing that the problem might be much, much deeper, that it lies in the very ingredients we assume the universe is made of in the first place. Just think about it for a second. Our starting point in physics is this whole list of separate things. You've got mass, time, distance, energy, and a handful of different forces, and we spend all our time trying to make them fit together. But what if that's completely backwards? What if nature is way, way simpler at its core?
And this is where a brand new framework called self-regulated curvature dynamics, or just SRCD, enters the picture. Look, in simple terms, it's a theory about how the geometry of the universe actually shapes itself. And it proposes this absolutely breathtaking idea. What if the universe isn't built from many things, but from just one single thing? And here it is. This is the whole shebang. According to the SRCD framework, the one and only fundamental thing is this ratio, energy divided by distance. You can kind of think of it as a measure of energy confinement, basically how much energy is packed into a certain amount of space. The theory then says that everything else we see, everything we measure, is just a different manifestation of this single ratio.
That's really the simplest way to put it. The entire cosmos, from the smallest quark to the biggest galaxy cluster, is built from different arrangements of this one single type of Lego brick. It's a massive shift in perspective.
And here's where it gets really wild. If that single ratio is the only thing that's truly fundamental, then some of our most basic, cherished concepts, mass, time, speed, even the forces themselves, they aren't fundamental at all. They're what we call emergent properties. It's like how wetness isn't a fundamental property of a single H2O molecule, but it emerges when you have a lot of them together. They're real for sure, but they aren't the primary ingredients.
Okay, this obviously raises a huge question. If there's only one building block, how on earth do you get the four wildly different forces we see in nature, right? How can gravity and the strong nuclear force possibly come from the same origin? Well, the answer lies in how this single ingredient behaves under different conditions.
And this curve is the answer. According to SCRD, all four forces are just different regions on this one elastic saturation curve. Think of it as the universe's master blueprint. That horizontal line at the bottom, the x-axis, that's our fundamental ratio U. It's how tightly energy is confined. The vertical line, the y-axis, shows how the geometry of space responds to that confinement.
So, let's take a walk up this curve, shall we? Down here at the bottom, where the curve is almost flat, energy is very weakly confined over vast distances. The geometric response here is gentle and long range. And what is that? That's gravity. It's so weak because it operates in the most relaxed, chilled-out region of the universe's geometry.
Now, as we move up the curve, we're packing energy in tighter, and the geometry starts to get stiffer. In this stable middle region, right here, we find electromagnetism. This part of the curve is what naturally supports the kind of long-range wave-like behavior we see with light and magnets. It all fits. Okay, getting closer to the peak now. Up here, where the confinement is almost maxed out, the geometry becomes what's called metastable, which basically means it's stable, but not permanently. It's strong, but it allows for a little bit of leakage, and this perfectly describes the behavior of the weak force, which is the force that governs radioactive decay. And right here at the very top where this curve is steepest, we have near total saturation.
Here, the tiniest little change in confinement produces a massive, massive response. This is the strong force, the incredibly powerful but super short-range glue that holds the nuclei of atoms together.
So what this all means is just incredible. The four forces aren't fundamentally different things at all. They are just different expressions of one single, continuous, underlying reality. The character of any force is determined simply by its address, its location on this universal blueprint.
We can also look at it this way. On a circle, it's the exact same idea, just wrapped around. You can see gravity taking up that big, relaxed region. Electromagnetism gets its own stable band. And then you see the weak and strong forces all clustered up at the top, where the confinement is maxed out. It's such an elegant picture, isn't it? Four forces, one single geometry.
All right, so if the four forces are just shadows of a single geometry, this has some truly mind-bending consequences for our other fundamental concepts. So let's start with the big one, mass.
We think of mass as this intrinsic property of matter. It's the very definition of stuff. But if this energy-distance ratio is all there really is, where does mass even come from? Well, in the SRCD framework, mass isn't a fundamental substance. It's more like a calculation. It's a quantity we derive that just describes how that ratio is configured in a particular spot. You can almost think of it as just a bookkeeping device for how much energy is confined. It's not the stuff itself.
And that brings us to the biggest, most mind-melting one of all. If mass isn't fundamental, what about time itself? What is the tick-tock of the universal clock really? Okay, this is profound. This implies that time doesn't flow on its own, like some cosmic river. Time is change. Specifically, it's the sequence of reconfigurations of the universe's fundamental U ratio. If the configuration of U across the entire universe were to just freeze, then, according to this theory, time itself would stop.
And this just completely collapses our whole idea of how things move. Time, distance, and speed. They aren't three separate ideas anymore. They're simply different perspectives, different ways of measuring the exact same underlying process, the constant redistribution of that single energy-distance ratio throughout the cosmos. This quote from the paper just perfectly captures the essence of this whole idea. It's this monumental shift away from a universe of disconnected parts and pieces and towards a cosmos that is a single, unified thing, constantly just trying to find balance.
Look, this framework is brand new. It has a very long road ahead to be tested and proven. But it leaves us with this provocative and kind of beautiful thought. We've spent 100 years digging for more and more complexity to try and unite our theories. But what if the answer wasn't more complexity at all? What if it was radical simplicity? Could the universe, in all its vastness and diversity, really be born from a single, elegant ratio?